Hey guys, I guess you can hear me. Hello.
கேக்குது.
Yes, Paras.
Yes. Okay. 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 Sorry, this Teams is getting upgraded or updated or what? I don't know because it was just loading for me for a while and then I had to upgrade it. So finally, I decided not to use the Teams app and I started using it in browser itself. Okay, let's just give 1 or 2 more minutes and then we'll get started. All right, I'll start with the attendance and then we'll get started. Balaji is there. We have Kamini Kumaresan. Venkatesh is there. Victor Sendal Meena. Manikandan. let's jump in and we'll get started. Just a second. Okay, let's begin. Let me share my screen and then we'll get started. Please let me know when you guys are able to see my screen. You guys are able to see my screen.
Yeah, I'm able to.
Okay. Okay. So first of all, before we jump in and get started, did you guys all try out what we did yesterday as part of yesterday's session?
Yes, Bharat. One
Yes,
executed
Bharat, right.
like a 7 and 8, and then it is working now.
Okay, great. So today what we are going to see is we are going to see the architecture of different LLM models. Okay. So when I say architecture, these are when I say BERT, GPT, T5, these are the basis of LLM architecture. But the current world LLM is different. Okay, this is a very old GPT architecture. Current architecture might be a little different, but it's more or less a high level, the same aspect, right? So, so that is how the, you know, the, sorry, I just got a little bit distracted. So yeah, so so this GPT architecture that we'd be seeing is going to be more or less the same with the current world GPT architecture. However, um, however, this is a little bit older version of, this is probably like 7, 8 years older, 7 to 8 years older version of GPT, right? So that's the main difference that we would be seeing, because today's GPT models are multimodal system, um, which I'll talk about as well. Okay. Just give me. All right. Let's jump in and let's get started. Just a second. Let me share the PPT. We'll go over. I never do PPTs, but for this one we need some. You guys know in the AI world, right? So let's call this as the bigger piece of AI, right? I'm just gonna color code it a little different. This is your AI, okay? So in today's world, this piece is rapidly growing, which is your generative AI. Can anyone say, like you guys all know what is generative AI, right? So can you guys say what is generative AI basically? Out of all these sessions, you guys must know what is generative AI by now, right? So can you give me like a few examples of generative AI aspects?
Bharat, we will train the existing data set using a machine learning model. Advanced version is LLM. So with that, whatever the information we can acquire as like a human, we can make use of the existing data set.
Um, it Bharat, it creates content
Yeah,
like images, text
yeah,
by
Exactly. This is
prompting.
what is Gen AI.
yeah.
Whatever is told right now, right? Gen AI is nothing but generative AI. What does generation mean? What does generative means? That means it's generating more. Basically, it's trying to create, right? So generative AI is nothing but creative AI. It just creates content. What type of content? Any type of content. It can create tabular data. It can create textual data. It can create images. It can create videos. It can create audios, anything as such, right? So this piece is called generative AI. Why this piece is important in AI is because in today's world, right? Let's say, if you wanted to make a PPT, I'm just making it up, okay? Let's say if you wanted to make a PPT. All right. So how would you do that in the past? You'd go to Google, you'd research on content by yourself, right? And then what you would do? Then you would convert it into pointers, and then you would write down those pointers, type them into a PPT, right? Correct? All of you agree with this, right?
Yes.
In today's world, with generative AI, which piece of this can you automate?
All of it.
Yeah.
Yeah, all of
Everything
them,
we can automate.
right? Initially, what happened? Yes, exactly. That's the right point. Initially, what happened? Just the research was provided by ChatGPT, right? So what happens? You put in a query, you can do the research, then the research will give you the pointers directly. Research to pointers, this was automated by AI, right? So what did you do? You did the research with these pointers. Then basically you entered these pointers into your PPT, right? That was the next step that happened as step 2, right? So this is a generative AI use case that I'm talking about, right? Next, what happened? They also brought in the search APIs, which enable the LLMs to do live searches, right? Do you guys know how LLMs are trained? Like with what data it is trained? So basically, typically until now, LLMs were trained, and even now, LLMs are trained using internet data up to a certain date. Okay. If let's say you ask a question about, have you guys used Jira? Most of you would have used Jira, right? Do you guys know what is Jira?
Yeah, it's a
It's
kind
agile
of
project
ticketing
management.
tool, agile tool.
Yeah, exactly. Right. So let's say in Jira documentation or API documentation, there's some changes that happened beyond this date. ChatGPT is not going to know about it. So then they made the LLMs to have live live internet search. So whenever you go to ChatGPT, right, here you have this option called web search. So this is the one that does web search, and based on the results of the web search, it makes those changes, right? So that started to happen. So this piece, you can go to web search from the web, and then that gets added into your research as well, right? So this piece also got automated. Let's understand this as step 3. Okay. Then in step 4, what happened? Okay, instead of me giving these pointers, why don't they started generating code as well, right? So in code, you can prepare PPTs. So what they started to do was they wrote a code for generating a PPT with this content. So they generated the content plus they generated the code for the PPT. So what happens together? PPT gets generated, right? Right. So this entire process can be automated using generative AI, right? So initially, before we jump in and get involved into these things, the diffusion model and architecture and other things, we're gonna try out a few real world applications, and then you're gonna understand a few real world applications. Okay. Say for example, this entire PPT, right? I just used AI to build this entire PPT. This complete PPT was built using AI. So I did not do anything. So do you guys know any, have you guys used any PPT building platform for, AI based PPT building platform?
Claude AI will do this, but
Claude
not
does it,
use.
but Claude, I don't think does it at this scale. So I'll show you guys a few examples. Okay. So we're gonna see what we're gonna try out is, first of all, in the first half, we're gonna try out a few online AI based platforms for different purposes. Okay. So let's start with this. Okay. So everyone will have to, this is again an exercise. I'm going to give you a few which you guys are going to try out. Plus, you guys are all going to bring in one AI tool that you see online, which is a generative AI based tool. Okay. I'm going to give you a few tools here. Okay. This will be again, like I'll give this in the course materials as well. Parallel web systems. What do? If you are running a business, you want to find leads for your business, then use this. This gives you free $80 credit on their platform. Free sign up, right? So the next thing is gamma.app to create a PPT, right? And then the next tool that you're going to use is I'll give you a task as well. So can you guys try these platforms that I'm just giving you here, and then try and understand how you can use it in your day in, day out life, okay? And this is not just for you to, you know, we are going to learn how these are working and everything throughout the course, right? But at the same time, we have to also enable ourselves to be a very quick AI user. So let's say if in your organization, if they are asking you to do a PPT, instead of taking like, probably an hour or two to do the PPT, if you can do a quick PPT, how that can enable you, right? That's one thing. Second thing is like, let's say if you want to generate a music, right? How quickly generating a music is not going to happen in your day in, day out workplace, but it's just for you to learn it, right? That's why I'm just, bringing in that as well. And then generating videos, right? Generating images, I think you all know by now, like, to use Gemini to generate images, right? That's why I wanted you guys to try out the video piece. And parallel web systems is something that is being built by, do you guys know who built parallel web systems? It is the Twitter CEO who got, thrown out of Twitter by Elon Musk. His name is Parag Agarwal. That guy built the parallel web system. So basically, these are parallel web system is very important for you guys to understand. Okay, just try these four things out right now, and then we will start with, once you're done with all of this, some of the real world applications of Gen AI, then we will get started with the core topic of, the architecture and everything. All right. Can you guys try this out right now? And then I'll give you a small task to do with these AI tools as well. Also, can you guys find one AI tool, each of you, which is free of cost in all these domains? It's a very simple research that you'll have to do. I mean, you can use ChatGPT, you can use anything for that, but that tool must be free of cost, right? Why we are doing this? The reason we are doing this exercise is because this exercise helps you to become an AI user as well. That can actually save time at your workplace as well, right? So, and you also get to understand what sort of, I have ChatGPT. What can I build using ChatGPT as my own startup or my own company, right? That's the idea. This piece, what we are trying to do here, gives you. Okay. All right. So you guys are doing it, or do you want me to do one of the examples for you guys? Okay, let's do
Bharat, can
Suno.
you do it once?
Yeah, let's do Suno AI. Okay, so I'm gonna let's do a little bit funny one. Okay, write a song lyrics about systems and generator AI.
So Bharat, what you're currently doing is like it's kind of a prompt engineering, like prompting to get the output.
Yeah, exactly. Yeah. So I'm just showing you what actually AI can do, right? Like what all things AI can do. So basically, I asked ChatGPT to write down some lyrics, right? So about Credo systems, right? So and then what I'm gonna do is I'm gonna go into Suno AI, and then over here I'm gonna paste this, and then I'm gonna hit create. I'm gonna sign up. Just a second. This tool, right, basically what it does is it can help you to create um, complete songs for yourselves. Okay, and then it just gives you free credits. This is not a typical IT use case as such, but I'm just telling you how powerful the AI has become, that it can actually sing itself for you, and it can basically we wrote the lyrics using chat gpt, we put it here, right? This can also help you write the lyrics as well, but it just wastes your credits. Are you guys able to hear it or no? Okay,
Yes, Bharat.
hold on, let me see if this works.
Stepping in the future, minds getting upgraded. Federal system got the vision activated from zero to genius.
You see the entire song is getting sung in a rap fashion because we mentioned that. So it was able to create this song in like few seconds. Imagine what sort of careers are being actually taken away, because you don't need like a band, you don't need musicians, you don't need music directors. Basically anybody can use this to create songs. So are you guys able to hear the song or
Yeah, well, we can.
Yeah, stepping in the future, minds getting upgraded. Credit systems got the vision activated. From zero to genius, yeah, they flip the switch.
So you see the lyrics here and the song over here, right? So this has been the power of um, AI in today's world, right? Okay, let's saw one. Let's see another one.
Bharat, like at the end of this time, yeah, of course, we are going to use this 15 and then other tools. Then at the end of the time, we are going to answer how it is generating. That is what we are going to see today, right?
No, no, no. You just have to figure out like tool names. That's it. You just
No,
come
no,
up with some
that
tool
I
names.
understand, but eventually,
Yes,
like
yes.
I need
Eventually,
to know I how it is doing because like
yes, you need.
everybody who
Yeah,
hmm,
yeah. So, yes, exactly.
hmm,
How piece is what I explained for one of these, right? So
hmm,
to create a PPT, how you can build a PPT generation, if you want to build a PPT generation platform today, right? You can do it by your own selves, right? How you can do it by yourself? You can ask ChatGPT because ChatGPT started doing it already, right? But there are certain areas of scope where these AI platforms have not yet solved for it, right? You may only have the data to solve for it. So your business only might have data to solve for it. Say, for example, let's take the case of 3D designing, right? Like what you're doing, right, Kumareshan? So let's take the case of CAD designs, right? If you
Actually,
prompt, you want the CAD design on the right side to be re-rendered every time based on a prompt that you're giving on the left side. Okay. So let's say you want to build something like that. That means the general ChatGPT, Anthropic AI might not have that much of data. They need to buy those data from someone in order for that AI to become that smart. Correct?
no,
You
no,
guys agree
this
with
I
that?
understand. This I understand because see, like some ChatGPT might have some limitations. Claude AI has limitations. Other AIs have some parallel web solutions. Will have some better solutions. Okay, so
Yes.
solutions and limitations that we need to know. That is one thing. But when I give a prompt, hey, write a poem and then sing the song in the rap mode or something like that, when you are giving the input, how it is taking, like encoding, decoding, those things that we have learned, and how it is going to generate a music. Like, okay, it is encoding and then converting into the numbers and then it is generating. So how
No,
it is
you don't need to
generating?
know at that level. This exercise is not for you to learn at that level. This
Mm,
exercise is for you to learn how you can use ChatGPT APIs to build tools like Suno AI. Suno AI is a tool that has been built on ChatGPT, Claude, and things like that. They do not own or have their own large language model, right? So a lot of AI startups or a lot of AI companies do not have their own AI. They basically use ChatGPT or Anthropic as their underlying AI model, but they just tweak that and they get like multiple different outcomes in order to form their own outcome. Say, for example, I'm just making this, right? If you wanted to do a PPT building platform, okay, how can you do that? You can ask, you can write two API calls. Just see if you understand this. You write two API calls. One API call, you do the architecture piece. I'm just doing the architecture piece, okay? You write one API call to just generate the PPT content from ChatGPT, okay? Everyone is clear with this? And another API call to generate a code to build a PPT structure or a template. Okay, you write one more API call to generate images wherever required in the PPT. And then you just have to write a piece of code that takes those images, puts it into that PPT, that takes these content, puts it into PPT. That is just code rework again. Like you just have to modify that code. For that, probably you do one consolidation ChatGPT API call, right? Just with ChatGPT itself, you can create better PPTs. How can you create best PPTs, right? That does not even, that is like super perfect, right? Like those kind of PPTs, how you can generate, right? That's what I'm telling you, but not from an underlying, like a low level work, but you use ChatGPT and Anthropic and these kind of APIs in order to perform this, right? That's what I'm trying to explain you guys. Is
No,
it clear?
this I understand, Bharat, because see, like you said, there are two APIs. One is going to call this Claude or Anthropic, sorry, some LLM tool using to, because I'm going to give a, hey, create a PPT about Gen AI, like that if I'm giving. So it has to call one LLM on this one API, and the another API has to, because my PowerPoint is a Microsoft Office tool. So it has to connect to the tool and then create a empty slide and then take the content. Okay, this is a Gen AI information. What is Gen AI? Who created Gen AI? When it is created? How it is used? Something like that. It has to put the words on top of on the PowerPoint and then make it as a presentable slide. Some add some images or add some data and then give it to us. So this generation, right? So like you said, like LLM connecting one API and then connecting to the Microsoft Office one API and then putting this on in a presentable mode. So this work, this process, it is doing some encoder, decoder, something like that. So how it is generating API that we are going to learn. Am I correct?
No, Kumarishan. So you're just learning the first piece, the first half of the session is just to learn how you integrate them, how you form the structure. Because you need to, you need to form an architecture with the AI itself to connect these in order to build a solution using AI itself. This is what is required in industry right now. This is what is expected in the industry. So that is what we are seeing. We are not trying to reinvent a wheel. Don't forget about encoders, decoders, everything. Let's say you're working for a company. They give you an LLM access and they're asking, what can you do with the platform? We already have a product. What can you do on that product with this AI? That's what is their question. How do you form an architecture to do something, right? So that's why I took a case of PPT where you have to architect in such a way that, let's say, probably you will architect to make one API call to do to get the content. You'll do one more API call to generate the structure. Like that, I'm saying that doing that piece, doing the number of API calls, how it generates this, how do you connect all of this? This architecture is what is important in the first place, is what I'm saying. Then we get into one level deeper. That we will do later. So don't worry about that right now. But doing this piece is the first piece that I want everyone to be on the same page. Others,
Okay,
do you all understand?
Yes, Bharat.
See, we are not trying to I'm trying to explain you guys to build an AI application using an existing AI that has been already built. You see what I'm saying, right? But that AI is not built for preparing PPTs. Or I should put it this way. This is all for, see, basically what we're trying to learn here is this. The real world applications of generative AI. This is what we are trying to learn here, right? So what real world application can you build using existing AI?
You mean today's class or this whole course?
No, in today's class, Kumaresan.
In today's
That's
class,
why I'm
okay.
saying only in the first half,
Okay. Okay, but then we can proceed with like using some stuff. So so do you
Yeah,
want us to
others.
generate some music or audio or what you want us to generate?
No. See, you guys just, do you guys understand this is what is my question? Because these are applications, but they do not have a large language model. That's what I'm trying to tell you guys. They're using existing large language models to build an AI tool that can solve business problems. So I'm just trying to explain you how you can solve real world problems using an existing large language model. That's the importance in as of now.
Bharat,
Others
if you,
Hmm.
sorry, Bharat, after you, yeah.
No, go ahead, please.
I just want to share my screen because I've just given a prompt in Chat GPT on the same what we are talking, right? It came up with a workflow with a code and also how the slide needs to be prepared. So
Yeah.
just want to show you, like, is it the right thing what we are trying to do here? 1 second, I'm just sharing my screen.
Yeah.
Let me know if you're able to see my screen.
Still a little blurry. Yeah, I can see.
So I just gave a prompt, how can I build an AI application to build PPT? So it came up with
Yeah.
this thing, then it came up with a workflow. AI generates slide outline, AI writes the content, Python PPTX creates slides and download.
Yeah, exactly. This is exactly what we are talking about, right? So this piece of doing these steps is what is expected in the industry as of today. Because see, let's take any company that you work for, right? You guys are all, some of you are already working for certain companies, right?
Yeah.
Most of the companies cannot rebuild a large language model within their own premises. Nobody is doing that. Okay. Large language model is being built by probably by, like, some hardly 100 firms in the world, right? And only they are building the large language models. But it is going to evolve to a fashion where every company builds their own large language model in the future. That's what is going to happen in the future. But for now, this is already being done by, let's say, a few companies, right? How can you use their large language model itself to quickly build an application is what I'm trying to teach you guys.
Mhm.
Is it clear? Is it confusing?
So basically from the Hugging Face, we will utilize their model and architect to develop something for our own benefit.
Exactly, yeah. For your company as well, let's say
Oh.
if we have a product, how can you build something with the existing AI? That's what we're seeing here. How about others? Like, do you guys understand what we are speaking here, or see, does everyone understand Tamil here? Who doesn't understand Tamil here?
It's
I'll
me,
put,
Bharat.
you don't understand Tamil, is it, Victor?
I understand a little bit, but not a fluent one here.
Okay, no worries. Then we'll keep it in English itself. That's fine. Now, it was just to see how I can explain it at one more level down. Say for example, see, I'm just trying to teach you that even today you can build AI applications that are required for a lot of different firms, right? So what I'm trying to say is you can still, even today, you can build AI applications without having to build an AI from scratch or a large language model from scratch. You can use these generative solutions. You can provide these generative solutions to, say, for example, if you're working for a company like Jira, okay? So until now, what was happening? Somebody had to write all the requirement content, correct? So if if Jira, what can Jira introduce as a generative AI application over there? Rather than writing all the content, you give 4 or 5 points. Based on those 4 or 5 points, I'll write it into a proper requirement format. If Jira brings in this feature, how useful it will be, right? If you're working for Jira as a company, this is a generative AI use case for that company. That is how I want you guys to start thinking. Do you get what I'm saying? To whichever company you're working for, generating text or generating images or generating video or generating audio, how it can substitute in the existing product that they have, and how you can make it possible is what you should start thinking, is what I'm trying to say, because this is what is expected in the market as of today. And how we do that is what we are going to see through the course. Is it Is it clear? Still confusing?
I think I'm good.
Okay. How about others? Others good? Kumareshan, you're good. You
Yeah,
get
yeah,
it?
yeah, Bharat. Oh, no, I'm
Okay.
good for now, yes.
Bharat, can you explain me in Tamil itself? Like I'm trying to
Okay.
make myself understand. Somewhat I'm understanding here and there. We are trying to build an app using AI. So
Yeah.
with different
Ipo,
generative AIs, whatever we have, we are trying to build. But how interconnection will happen? How we will build it?
how it will happen வந்து we will see it over the period of course. பட் நான் என்ன சொல்ல
Okay,
வரேன்னா நீங்க
okay.
நீங்க இப்போ
Ah,
பேசிக்கா நான் என்ன சொல்ல வரேன்னா நீங்க
mm,
இப்போ வந்து உங்களோட எக்ஸிஸ்டிங் கம்பெனிலேயே வந்து ஒரு ப்ராடக்ட் பேஸ்ட் ஃபார்ம்ல நீங்க ஒர்க் பண்றீங்கன்னா அவங்க வந்து ஒரு ப்ராடக்ட் வச்சிருக்காங்க. அந்த ப்ராடக்ட்ல
mm.
லெட்ஸ் சே அந்த ப்ராடக்ட்ல வந்து ஏஐ யூஸ் கேஸ் இம்ப்ளிமெண்ட் பண்ணுங்க அப்படின்றது தான் இன்னைக்கு மோஸ்ட் ஆஃப் த கார்ப்பரேட்ஸ் ரெக்வயர்மெண்ட் இஸ்.
Correct.
Most of the corporate is saying that okay, just go ahead and implement AI in my product. This is what
Yeah.
is expected in the market. இப்போ நீங்க எந்த ஜாப் ரோல் நீங்க அப்ளை பண்றீங்கனாலும்
Mm,
if you are a generative AI engineer, that means you can implement a generative AI solution in your existing
mm.
product. ஓகேவா? அதுக்கு
Yeah,
எப்படி
yeah.
நம்ம திங்க் பண்ணணும்ன்றது தான் வந்து ஐ எம் ட்ரைங் டு எக்ஸ்பிளைன் இட் ஓவர் ஹியர். சே ஃபார்
Okay.
எக்ஸாம்பிள் இப்போ நீங்க ஜீரா கம்பெனிக்கு ஒர்க் பண்றீங்கன்னு வச்சுக்கோங்களேன். அதுல என்ன
Mm, mm.
பண்ணுவாங்க, வாட் வில் யுவர் கஸ்டமர்ஸ் டூ? கஸ்டமர்ஸ் வந்து உள்ள வந்து ரெக்வயர்மெண்ட்ஸை டைப் பண்ணுவாங்க, கரெக்டா? அந்த
Correct.
ரெக்வயர்மெண்ட்ஸ் இவ்வளோ நாள் டைப் பண்றதுக்கு வந்து லெட்ஸ் சே இட் டுக் தெம் லைக் ப்ராப்ளி 1 hour ஃபார் ஒன் டிக்கெட் ரெக்வயர்மெண்ட்ஸ் ஃபுல்லா
Okay,
ப்ராப்பரா ஃபார்மேட்டடா டைப் பண்றதுக்கு. பட் டுமாரோ இஃப் தே
okay,
கேன் ரெடியூஸ் இட் டு லைக் 5-10 minutes, they can write more tickets.
okay, okay.
ஸோ அதை எனேபிள் பண்ணோன்னா என்ன பண்ணாங்க, ஜென்ரேட்டிவ் ஏஐ யூஸ் கேஸை வந்து ஒரு ஒரு ஒரு
Mm,
பட்டன் மாதிரி வச்சுட்டு யூ கேன் ஜஸ்ட் சே தட் யூனோ ரீஃப்ரேஸ் திஸ் கான்டென்ட் இன்டு மை ஜீரா
mm,
டிக்கெட் ஃபார்மேட் அப்படின்னு போட்டிங்கன்னா உங்களோட டிக்கெட்
mm,
ஃபார்மேட்டுக்கு ஏற்ற மாதிரி அது வந்து நீங்கள் ஹிட் பண்ணிட்டீங்கன்னா ஒரு 4 பாயிண்ட் மட்டும் எழுதிட்டு ஹிட் பண்ணீங்கன்னா அந்த ரெக்குவயர்மெண்ட் அது பில்ட்
mm.
பண்ணிடும். அந்த பர்டிகுலர்
Okay.
ரெக்குவயர்மெண்ட்ஸ் பர்சன் கேன் ஜஸ்ட் ப்ரூஃப் ரீட் இட். இது வந்து ஒரு யூஸ்
Mm,
கேஸ்ன்னு நான் சொல்ல வரேன். ஸோ இந்த மாதிரி
mm,
லெட்ஸ் சே விச் ப்ராடக்ட் டு யூ ஒர்க் ஃபார் காமினி?
mm, mm, mm. Working for our Outlook, all SharePoint relevant product ஒண்ணு. Generica நீங்க என்ன சொல்ல வரீங்கன்னா, like if they give us some scenarios, we will be break down into use case first, and which is the best product we can use it. And the use case க்கு எது best product that is what you are sharing different AIs, parallel web system, Gamma. இந்த எது for
இதெல்லாம் வந்து
example, PPT
எக்ஸாம்பிள்ஸ்க்காக காமிக்கிறேன்.
example.
இதெல்லாம் எக்ஸாம்பிள்ஸ்க்கா. சரி லெட்ஸே வந்து உங்களுக்கு வந்து இன்டர்னலா வந்து உங்களுக்கு வந்து லெட்ஸே தேர்
Oh.
ஆஸ்கிங் யூ டு
Mm,
ஆட்டோமேட் சம்திங். லெட்ஸே ஒரு
mm,
ஒரு
mm,
ஒரு 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 என்வாயர்மெண்ட் வச்சிருக்கீங்க. அந்த என்வாயர்மெண்ட்ல டெஸ்டிங் எல்லாம் நடக்கணும். ஆட்டோமேட்டடா டெஸ்ட் நடந்து அந்த டெஸ்ட்
mm,
ரிப்போர்ட்ஸ் வந்து மெயில் வர்றதுலேருந்து வந்து ஒரு சம்மரி ரிப்போர்ட் ஜென்ரேட் பண்ணணும் அப்படின்றது
mm,
ஒரு
mm,
இதுல இந்த சம்மரி வருது. அதுல வந்து
mm,
ஒரு ஜென்ரேட்டிவ் ஏஐ யூஸ் கேஸ் இம்ப்ளிமெண்ட் பண்ணுங்கன்னு சொல்றாங்கன்னா வாட் யூ
mm,
கேன் டூ
mm,
இஸ் பேசிக்லி இந்த சம்மரி ரிப்போர்ட் இமெயில் வருது இல்ல, அது எல்லாத்தையும்
mm,
வந்து அந்த எல்லா டேட்டாவையும் யூ கேன் சென்ட் இட் டு சாட் ஜிபிடி. ஆஸ்க் சாட்
mm,
ஜிபிடி டு ஜென்ரேட் அன் எக்ஸிக்யூட்டிவ் சம்மரி. ஏன்னா ஒரு let's say for senior director or a vice president may not have the time to go over
mm,
each and every email, கரெக்டா? ஸோ
mm,
அதனால ஒரு
mm,
இமெயிலா அவங்க போய் பார்க்காம அவங்களுக்கு வந்து எல்லா இமெயில்ஸ்ல இருக்கிற எல்லா நம்பர்ஸையும் கம்பேர் பண்ணி இந்த இது இப்படி இன்க்ரீஸ் ஆயிருக்கு, இங்க பக்ஸ் வந்து இந்த மாடியூல்ல குறைஞ்சிருக்கு, இந்த மாடியூல்ல பக்ஸ் வந்து இன்க்ரீஸ் ஆயிருக்கு அப்படின்னு சொல்லி ஒரு
mm,
எக்ஸிக்யூட்டிவ் சம்மரி ஒரே ஒரு பேராகிராஃப் மட்டும் இது பண்ணிட்டு அதை மட்டும் மெயில் பண்ணீங்கன்னா எப்படி இருக்கும்? ஸோ திஸ் இஸ் அ
mm,
ஜென்ரேட்டிவ் ஏஐ யூஸ் கேஸ். I'm just
mm,
telling
mm,
you to think in these lines because this is what is expected in the industry right now. Because I was also talking to one of my other friend in
mm,
another firm. So அவங்க company எல்லாம் they are looking for generative
mm.
people who can implement such generative AI use cases. So that is what I am
Okay.
trying to tell when we are looking at real world generative AI use cases. It is nothing. எங்க நம்ம வந்து text generate பண்ணோம்னா will it be useful அப்படின்றத திங்க் பண்ணி அந்த இடத்துல வந்து இந்த டேட்டாவெல்லாம் கன்சாலிடேட் பண்ணி அதுக்கு மேலே ஒரு ப்ராம்ப்ட் வச்சு அந்த ப்ராம்ப்டோட அதை சாட் ஜிபிடிக்கு அனுப்பிச்சோம் இல்லை கிளாடுக்கு அனுப்பிச்சோம்னா கிளாட் வில் கிவ் அஸ் அ ரெஸ்பான்ஸ் பேக். இது ஆட்டோமேட்டடா ஏபிஐ வழியாக
Okay.
பண்ணோம்னா அதை உங்கள் அப்ளிகேஷனுக்குள்ளேயே இன்டகிரேட்டடாக இன்பில்ட்டா இஃப் யூ பில்ட் இட் தென் வாட் ஹேப்பன்ஸ் it is much more easier for the everyone in the loop to do it, right? So
Got it.
that's
Got
the
it.
idea.
Clear, Bharat. Manually, அவங்க என்னென்ன task எல்லாம் பண்றாங்களோ அது எல்லாத்தையும் we have to capture with generative AI how best we can automate and make that
Exactly.
work
With
simple.
generative AI, how best you can automate it. Yes.
Automate and make it simple, and underlying to that, what is the best technology within generative AI we can make use of it, and the organization என்ன eligible இருக்கோ, with that we have
Correct.
to do it. Clear.
Yes. Yes.
And these are all
Exactly.
different type of AIs models, like which is the best one? Gamma app, right, for creating app. So you ask us to test those, like how it is working,
Correct.
prompts, but they understand. Clear. Thanks
Correct.
for providing.
Yeah. No problem. That's fine. No issues. All right. So everyone is, until here, everyone is clear. Correct? Any further questions? Okay. So let's now quickly get into the architectural piece. This is going to be a little bit of theory. Okay. All right. So let me keep it in very simple terms. ரொம்ப complicated pogala. Okay. So do you guys know what is a transformer, right? By now. So okay, transformer கூட விட்டுருங்க. Encoder, decoder எல்லாருக்கும் ஞாபகம் இருக்கா? Everyone, so I mean, let me keep it in English. Everyone understands encoder and decoder here?
Yes, sir.
Yes, sir.
Yes, sir. So what does an encoder do? It takes the number of neurons in the first layer is more compared to the number of neurons in the last layer of the encoder. Correct? Encoder, what it does is encoder shrinks your data into a latent space. Decoder takes that latent space and then it can expand on that data back again. Correct? This process is called distillation. Encoding or decoding, this process is called distillation. Okay. So, diffusion and distillation. I mean, distillation is the process. The models are called diffusion models. Okay. So within diffusion models is what we saw. We already saw diffusion models where we saw autoencoder, variational autoencoder, and the advanced level of that diffusion model is called generative adversarial network, which we'll come to next. Okay. But you guys at a high level understand what is an encoder and a decoder, correct?
Yes, Bharat.
Okay, great. So when you're encoding and when you're decoding, what happens is, what you have to understand is all of these three are encoder decoder based models. Okay. Let's compare this with just the traditional models. What were some of the traditional models we saw? We saw RNN, LSTM, right? They were sequential models, correct? Imagine this is how your neural network is. Let me just open this up, RNN. Okay. So let's say this is actually your RNN architecture. So imagine there are multiple, this is every single layer. Okay. So this is like one layer and this is your output. L is your output. X is your input. Okay. Let's say you have a word, the cat sat on the wall. Okay. It'll start from here. This will be this X will be this will be cat sat on the wall. Basically, t minus 0, t plus 1 is like different times c. So this will have the first word. This will have the second word, the cat. This will have the third word, sat on the wall. Okay. This will have this sequential. This is the normal neural network. Correct. Recurrent is what happens is this data gets passed from top to bottom. This data gets passed top to bottom. This data gets passed back top to bottom. I'm just trying to get a good image of that. Let me just see 1 second. Just give me 1 second. Yes, this is how it works basically. It is still, I don't see the connections from top to bottom here yet. All right, it's fine. Let's keep this itself. Okay, this is still fine. You guys understand this X is your input, right? The cat sat on the wall. Okay, imagine there are more words here. Every word goes into here. Okay, and typically how neural networks are connected, imagine this is tilted like this. The neural network that we draw like this fashion is drawn this fashion from bottom to top. That is how it is drawn over here. First of all, do you understand how the neural network is here in this space? Instead of drawing from left to right, we have drawn it bottom to top. That is clear. Yes or no? Is it clear?
Yes.
Okay. So when we are sending your sentence as an input, you break your sentence into what? Tokens. So every single word, imagine for now, is a token. The traditional models depended on sequencing. When I say sequencing, what basically happens is the traditional models typically work like this. Okay. So they start with the cat sat on the wall. Let's say if this is the sentence. The sat cat on the wall. It cannot form a sentence like that, right? The sequencing of the words were very important. This is what we thought through all along. Okay. So what we did, we always maintain the sequencing of a sentence, and we built neural network architecture like that. That was computationally very much exploitational. Do you understand what I'm saying right now? Anyone who does not understand what I'm saying right now?
What time it takes?
See, given let's take I'll explain it in Tamil first, and then also I'll explain it in English, so everyone will understand. Okay. See, ஒரு sentence இருக்குன்னா, the cat sat on a wall அப்படின்னு ஒரு sentence இருக்கு. ஓகேவா? இந்த சென்டென்ஸை வந்து ஒரு நியூரல் நெட்வொர்க் ஆர்கிடெக்சருக்கு புரிய வைக்கணும்னா, ஓல்டன் டேஸில் நம்ம என்ன நினச்சோம்னா, தட் இதை சீக்வென்ஷியலாக இதோட இன்ஃபர்மேஷனை மெயின்டைன் பண்ணோம்னா மட்டும்தான் நம்ம மிஷின் லேர்னிங் மாடல்ஸால் புரிஞ்சுக்க முடியும்னு நினச்சி அந்த மாதிரியான ஆர்கிடெக்சர் தான் பில்ட் பண்ணும் இந்த பாஸ்ட். வை டிட் வி டூ லைக் தட்? பிகாஸ் த சாட் கேட் ஆன் அ வால் அப்படின்னு நம்ம வந்து ஒரு சென்டென்ஸ் ஃபார்ம் பண்ண முடியாது. கரெக்டா? ஸோ சீக்வென்சிங் ஆஃப் வேர்ட் இஸ் வெரி இம்பார்ட்டன்ட் இன் அ இங்கிலீஷ் சென்டென்ஸ் இன் ஆர்டர் டு அண்டர்ஸ்டாண்ட் த சென்டென்ஸ். இப்போ நான் சொல்ற பாயிண்ட் புரியுதா? வை சீக்வென்சிங் ஆஃப் சென்டென்ஸ் இஸ் இம்பார்ட்டன்ட் அப்படின்னு. தென் ஐ கம் டு RNN. இப்போ நான் சொல்ற கான்செப்ட் புரியுதா? ஸோ இந்த சீக்வென்சிங் வந்து மெயின்டைன் பண்ணணும் அப்படின்றதுக்காக பில்ட் பண்ண ஆர்கிடெக்சர் தான் ரெக்கரண்ட் நியூரல் நெட்வொர்க். வாட் ரெக்கரண்ட் நியூரல் நெட்வொர்க் பண்ணுன்னா, the cat sat on a wall. Every single word, the அப்படின்ற வேர்டோட ஒரு வெயிட்டேஜ் வந்து கேட்ல இருக்கும். கேட்ன்றதோட வெயிட்டேஜ் சாட்ல, த கேட் அப்படின்ற வெயிட்டேஜ் சாட்ல இருக்கும். த கேட் சாட் அப்படின்ற வெயிட்டேஜ் வந்து ஆன்ல இருக்கும். த கேட் சாட் ஆன்ன்றதோட வெயிட்டேஜ் ஏர்ல இருக்கும். த கேட் சாட் ஆன் அப்படின்றதோட வெயிட்டேஜ் வந்து வால்ல இருக்கும். அப்போ வந்து என்ன ஆகுதுன்னா இந்த சீக்வென்சிங் வந்து மெயின்டைன் பண்ணிட்டே வரும். RNN, LSTM எல்லாமே இந்த மாதிரியான மாடல்ஸ் எல்லாமே வந்து சீக்வென்ஷியல் மாடல்ஸ். இது எல்லாமே இந்த வெயிட்டேஜை மெயின்டைன் பண்ணிட்டே வரும். இந்த வெயிட்டேஜ் மெயின்டைன் பண்ணுறதுனால என்ன ஆகுது, இது அடிஷ்னல் காம்ப்ளெக்சிட்டி டு மெயின்டைன் தீஸ் வெயிட்ஸ். இந்த வெயிட்டுக்கும் நம்ம டிஃப்ரென்ஷியேஷன் பண்ணணும். டிஃப்ரென்ஷியேஷன் பண்ணணுங்கிறது வந்து ஒரு கம்ப்யூட்டேஷனலி எக்ஸ்ப்ளாய்டிவ் ப்ராசஸ். அது ரொம்ப கம்ப்யூட்டேஷனலி ஹெவி ப்ராசஸ். ஏன்னா ஒரு ஒரு வேர்டுக்கும் அகெயின் 768 டிமென்ஷன்ஸ் மினிமம் நம்ம வெக்டரைசேஷன் பண்ணோம்னா அந்த 768 டிமென்ஷன்ஸ் வந்து அடுத்த இதுக்கு போகிறப்போ அதுலேயும் வந்து அந்த 768 + 768 மெயின்டைன் ஆகும். அடுத்ததுல 768 × 3 மெயின்டைன் ஆகும். அடுத்ததுல 768 × 4 மெயின்டைன் ஆகும். கரெக்டா? ஸோ லைக் திஸ் we were maintaining the data in the past in recurrent neural network. That is why recurrent neural network was very computationally exploitive. But it also worked really well because it tried to understand the sequencing of the sentence. Okay, wow. Everyone understands why this is, what is happening in recurrent neural network right now? Any questions here? Except for Victor. I'll explain it for Victor in English again.
No, I understood it, Bharat. So one thing, this dimension of 768 or whatever based on the model, right? So
Yeah.
why we have a dimension? Is it because the model wants to learn it in a better way so that it gives us a right output?
No, that is the embedding process. Embedding process is little different. Okay, see, embedding process, I'll explain it. Why we do a separate embedding process? Let's say you take all the words in dictionary and then you take all the big sentences that are available in the world across different literatures and everything, and then you run it through a model. In order for that model to come across, the goal of the model is to give you certain numbers based on how that word is connected with every other word, right? So based on that, whichever things are important, you're keeping that and you're forming numbers. Those numbers will have semantic relationship. Those numbers will have contextual relationship. Those numbers will have that word zone importance itself and things like that. So let's say that is what is that process. And every embedding model also again is complexity versus time versus computation, right? One model is 768 numbers means it may not do complete representation of the word. There is another model which has OpenAI 3 embedding large. This model has 3000. This gives you 3000 numbers for every word you give. That means it has better understanding and it has better representation of that word, right? So that's what it is about. So that number is defined by the person who has built those machine learning model, right? So they think that this many number of numbers are enough for representing the word in English dictionary itself. Tomorrow new words may get introduced and those words may not be understandable by that large language model, right? So that's how it keeps evolving.
No, you said right. The cat sat on the wall, right? The
Yeah.
positioning of those sentence and the weightage of each and every word towards the upcoming word. It is all how that machine is able to identify that this word is the previous word to the next word, right? So it is
That
able.
we give it in that order. So that is this recurrent neural network architecture itself. So when we feed the data, the first data goes into the first word goes into the first neuron. Second word goes into the second neuron of the first layer. So let's say we saw this, right? So TensorFlow playground we saw, right? So here, the goes here, cat goes here, sat goes here, on goes here, the goes here, wall goes here. But here, these are all different inputs, right? In recurrent neural network, these will all be sequential input. The entire sentence in the first layer goes like that. That's how it knows that.
Okay, so we are giving it in sequence, right?
Yeah, we are giving it in sequence. Yes, yes.
Okay.
But the problem or the drawback of RNN is what you need to understand in order to get to transformers itself. The drawback of RNN is that the drawback of recurrent neural networks is that if you use recurrent neural network, it is computationally extremely exploitive. So it maintains all of the sequential data. Why do you have to maintain sequential data? You don't need sequential data. What we understood little later was um, that's why large language model, we were not able to solve for large language models 10 years back or something. We still had large language models, but they did not perform this well, mainly because of us taking all of this data sequential in a sequential fashion, that these generative models did not actually give better results. But right now, what is happening is we don't so in encoder, what happens? We only focus on the core features or we only focus on the important words, right? The sequence was mainly maintained for identifying only important words. Which word come after which word? We just wanted to understand which words are important, and based out of that, we wanted to do stuff, right? So this particular model, this particular transformers, it did not even worry about sequence. You just given the data, but you also tell what position of the data is. You just feed in the positional embeddings as well. So coming back here, right? So here you're giving the positional encoding and the input embedding. Input embedding is what your token based embedding, right? Let's say the cat sat on the wall, the cat sat on the wall, and then you also provide your positional encoding. Positional encoding is what is the position, and you do that position mapping, right? Which word is in which position. You just tell which word is in which position. But this architecture does not work sequentially. The cat will not have both the and cat's value. That is not how it works. Basically, based on the position, it'll align everything, and then it'll basically shrink all the cat sat on the wall, it'll shrink it. That might just say that cat sat wall. That might be the outcome in the latent space. Cat sat wall, and it might just have three embeddings. Those embeddings might relate to cat sat wall very closely. Okay, because it is shrinking, exact words may not be formed. It may form very similar embeddings, which may very closely relate to cat, sat, and wall. Okay, because it is shrinking that information, right? That is what is more important. This is what encoder did. And when decoder comes into picture, decoder, based on what all it has learned, it might generate a list of embeddings. Those embeddings might be the cat sat on a mat. It might even generate that, because if it has seen more data related to mat, it might just say the cat sat on the mat, not on a mat. It might even do on the mat. It might generate embeddings which are closer to these values. Then once we just only get the embeddings. After we get the embeddings, we use a tokenizer to convert it back into tokens. So when we convert it back into tokens using that tokenizer, embeddings are what? Embeddings are just numbers, those 768 numbers that got generated. Right? When we go through the decoder phase, when this happens, then basically what happens is we can convert it back into numbers. We can convert it back into text, and that is what we see out of it. Okay, so transformers can actually do encoding and decoding. The one that was there before transformers were GPT and BERT. GPT was a decoder only model. BERT was an encoder only model. So BERT, what you can use encoder only model for? Encoder only model, you can use it for text summarization problems. Correct. Let's say you give a paragraph of text. You want to understand which category or which which label it belongs to, like what we did yesterday, right? What did we do yesterday? We gave a sentence and we asked it which domain does it belong to, and you guys tried literature, language, social, politics. You guys did a different finance, different topics, right? Which topic does it belong to, right? That one BERT works really well because BERT consists only of encoder. Okay. Whereas GPT consisted only of decoder. If it only has decoder, what it can do, you give it one single word, it can generate a list of it can generate a paragraph about that word. You give a topic, it can write a essay from that topic. It may not be able to take much inputs. You guys get what I'm saying? So GPT was only decoder only model. BERT was encoder only model, but transformers are a combination of encoder decoder model. So basically, you can give a paragraph and you can get a paragraph output. You can give a large set of data and still get a large set of data as an output. So that is why transformers, and mainly transformers involved self attention mechanism, which is also there in BERT and GPT as well. So they both basically combined together is what is transformer. So this paved the way for looking into the important words and generating big paragraphs out of it. All right, let me pause here. Any questions here? Any
Now,
question?
if transformer has both decoding and encoder, right? Because it's a mixture of GPT and BERT, then why people are using GPT and BERT? That is not required, right? Everybody will move into transformer.
No. Again, everything has its own purpose, right? BERT works really well in topic summarization. Like, let's say you give it a big paragraph of text from some sort of a book. It can tell you which book it is from. The author probably is Agatha. Who's the author for this book, or what is this? What is the genre of this particular paragraph? If you ask it, it might say crime thriller, right? In doing in getting like 1 or 2 word outcomes out of a big paragraph, BERT works really well because that is specifically off of that. And GPT works really well in this space. Transformer, it is just architectures. Okay, these are not models, these are architecture of certain models. In today's model, it is even more better transformers are being used. And why this was named transformer is basically because if you know how an electric transformer functions, that's the same way. It is basically doing that adapting process or an adapter process. So when you get a current from a different, if you guys know AC, DC current, I can talk a little bit more around it, but yeah, not to confuse you. It can take bigger input and it can convert it into bigger output. That's what it basically does.
So if I understand in layman terms, transformer acts as a balancing element. GPT will act as an shrinking element, and BERT might act as a decoder element, right?
No. BERT is the shrinking
Okay,
element.
sorry. Yeah,
GPT
yeah.
is the GPT is the generative element. That's why G stands for generative pre-trained models, right? So yeah, it's a generative model. So this generates data. BERT does not generate data. BERT tries to understand the core crux of the data. Then what transformer does is transformer can understand the core crux of what you've given, then generate data. So when you give a paragraph, it can understand the core crux based on BERT's architecture. Then based on GPT's architecture, it can generate data. Think of it like that, okay? GPT is generative pre-trained model, but actual chat GPT full form is generative pre-trained transformers. So they use transformers replacing the GPT itself. So that's why they named it chat GPT itself. Chat GPT full form, if you do it. Yeah, see, generative pre-trained transformers. So they use transformers. All right. Anyone else? Any other questions? Any doubts? Any thoughts? Is it clear? Is it understandable?
But actually, are we going one layer by layer? Like, see, actually, in this architecture, the first layer will do this, second layer will do this, something like that.
See, I can even go to that level, but for that, you need to first start to understand from neural network layer on layer, because it's all from see, when it comes to multi-head attention, right? That is multi-head attention itself. First of all, you need to understand what is attention. You need to understand what is multi-head. Then you need to understand what is feed forward, what is backward propagation. There's so many prior terms in normal deep learning itself that you need to understand. So that is the reason I don't go at that level, because I can explain that, but you may not be able to understand it in a single day. That's what I'm trying to say, Kumreshan. You need to understand the basic crux of how neural networks work, how the how the um, how the transformation of how the math works in neural network first. Then only you can understand these layers. Then only you can get to the next levels. That's the challenge here.
No, at least a high level, Bharat. I mean, like, see, actually, this is taking something and then converting to numbers, something like the high level, it is enough because we
See,
don't need
high
to know
level is
actually the
exactly
human.
what I said. High level is exactly what I said. High level is encoder takes, your sentence, and then it just exits out just those words. That is what is high level. So that is what exactly happens over here, Kumareshan.
No,
You,
imagine you are giving a prompt to write a song and then do it in a music, like in the music form. There is some voice generated and then music is also generated. So here we are giving the like a sentences input. Okay, and then it is generating a song and then generating a music and then
no,
singing it.
for that, that's a completely different architecture. So that does not only use transformer for audio generation, there is a different architecture altogether. So I cannot explain in other domains. That is why I'm explaining only in text domain. Transformer is mainly used in text domain. Transform architecture is modified depending on use cases as well. So it is not a single architecture, or it is not a single thing that you see what I'm saying, right? It's like flavors. When you can eat vanilla, you can eat butterscotch, you can combine vanilla and butterscotch, and you can eat like that. The layer level, it changes, everything changes. But here, what happens is when it comes to encoder, simple terms, that's exactly what I said. Leave off audio generation use case. Take the same text generation use case that I talked about, right? The cat sat on a wall. You're on the same page with that.
Yeah, yeah, that I understand clearly. Yes.
So that one gets, when it gets shrunk, right? When it gets convoluted, I shouldn't use the word convoluted, but for now you can use the word shrunk, because convolution is a different mathematical thing. In image processing, to shrink the data, they use a process called convolution, but they do not use the convolution process here. They use a different process to shrink the data here. So even shrinking process is different in different domains. But yeah, but anyways, coming back to the topic, the cat sat on a wall, right? When you want to just identify the important words, that is what encoder does it for you. Cat sat wall. The cat sat on a wall, right? The on a gets deviated, and cat sat wall, and embeddings that are relevant to cat sat wall, not exact word gets formed, just similar ones may get formed in the latent space. And I'm saying may because the model generates it, so nobody knows exactly what it is going to do it, because again, this is the best ever loss rate that we have achieved thus far. So it might be very closer to the best ever loss rate that we are expecting it to achieve, right? So that's why it's a black box. Nobody can say that it will achieve this, it can do this, it can do that, until and unless we explore it as use cases. Okay, so cat sat wall, and similar to cat, there might be an embedding there. Similar to sat, there might be a different embedding there. Similar to wall, there might be a different embedding there. So, or these three combined together, if there's something relevant to that, that embedding might be there, right? So this is how the latent space would have, because now we can say that this has all the important stuff from your sentence. That is what your latent space is going to have. This is the outcome of your encoder. So this is the input of your encoder is your sentence. Output of your encoder is that. That is what you mainly need to know.
Okay, okay, Bharat.
But if you see, if you want, I can go over, I can go over normalization. See, basically here, basically, it has normalization layer. So basically, first of all, you need to understand what is normalization. Uh, uh, so, okay, then we'll have to get into normalization. So normalization itself has different types of normalization. So let's assume that we are doing the standard normalization. There's like people typically do normalization or they do something called as scaling. So if they do scaling, then it again goes to min-max scaler, standard scaler. There are different types of scaler. If it's normalization, then they bring the value into a particular range and then they convert it into. Do you know what is normal distribution? Right? So they convert your data into normal distribution. So whatever data you have, it gets converted into normal distribution. So that is this process, normalization process. But they don't do normalization for the entire data set. When you're training, they convert, you can send data in batches. Okay. So you have a batch size that actually goes and sets accordingly to your hardware limits. So let's say if your hardware is x64 hardware, then typically the batch size would be set in multiples of 64. So, you may set your batch size as 64, or let's say you might set it as 3600 and odd something it comes to. Like that, you have a range in which you set. Okay. Once you set your batch size to that, just for that batch, you take all of that data and then you normalize that data for that batch alone. So this process is called batch normalization. You do this process before you send the data over there. So how batch normalization can be applied? So even before batch normalization, what you do is you converted them into embeddings, right? Basically, they're just numbers, right? Those numbers have to be normalized for those levels. So now if you understand, let's say the cat sat on a wall, right? This is just one sentence. Like this, you may send when you're training the data, you may send three, let's take the batch size is 64. You're sending 64 different sentences. You want to bring all the 64 words into a small graphical entity where the values are not varying too much. So that is why you apply normal distribution on these 64 sentences. But these 64 sentences may have all different words. So you try to bring all these words into one single, you just bring them into a how to put it? You bring them into a space where it is all uh, smaller size space, right? So that is what you try to do as part of this process. Then you apply, multi-head attention. And again, attention mechanism is a whole deep topic in itself, right? So that's the reason I'm not, getting in depth. You cannot understand it in like one single day or something. If you want, I will do it separately, but I mean, it's a whole big topic in itself, right? You need to understand the mathematics behind it. You need to understand the what to say. You need to understand how the word flow itself happens end to end. So let me see if I can find some images.
At this higher level, Bharat, like this all like whatever normal distribution or like the differential calculations, any kind of a mathematicals, that will be like a algorithm. So it will pass on some algorithm and then it will generate some output. Is this high level understanding correct?
Yes, correct. Yes. No, I'm trying to understand what you exactly want. That is what That is what is
No,
my.
see, imagine, yeah, like when someone is asking me, hey, how, like, okay, I'm giving an image and make Anushka to smile, so then it is giving this output. So how it is actually doing? So anybody can do that image processing, but how it is actually, excuse me. So how it is actually doing that? I should be able to answer that question. That is why, like, when I
Makes
finish
sense.
this Gen AI
Yeah.
course, then I should be able to answer that question.
Yeah. So see that piece is the same way that I mentioned to you, Kumaresh, and whatever I said, right? That explanation is enough for the interviews because they're not going to ask you like, what happens inside of a particular layer. That means you need to get prepared at that lower level as well. But at a high level, the explanation that I'm giving you is what is typically seen in the interviews as well. Typically, see wherever you go as well, typically people talk at this level only because see, you don't talk at Python is based out of C++, right? Nobody talks at like, what is happening at an assembly level or, at that level, right? But if you learn that, that is well and good. I'm not saying you should not learn that. But I'm saying you can, if you learn that, that is the best approach. But that does not come in like one single day or something is what I'm saying.
Okay, understand. Okay.
Let me see if I can. And see, you cannot apply transformer directly on every single thing. Okay, so let's start here, right? So tokenization, this piece you understand, right? So this got converted into tokens. Then tokens get converted into embeddings. Everyone understands this, right? So there are 6 tokens, 768 dimensions, right? Then what do? We do positional encoding. So what do? Embedding plus position vector. What is the position vector? This is position 0, this is position 1, and so on and so forth. We are adding that, right? Yeah. So now in the self attention layer, so this is where the transformer layer comes into picture. So in the self attention layer, what basically happens is it looks into the important words. For example, cat, sat, it is looking on the word on because it is, giving some relation, but this is at a high level. So each word, look at every other word and decide what actually matters. What is the important word? That is what the self attention looks into. Okay. And then it just tells you that these are out of all these words, the important words are like sat, cat. Okay. These are the important words. This is what the self attention layer looks into. Then in feed forward neural network, what basically happens? It takes these word, then sends it to a uh, linear network. Then basically they apply ReLU function on top of it. ReLU function is what? We saw a ReLU function, right, in the last session. So can someone tell me what is a ReLU function? What it does? ReLU is what? Rectified linear unit. What it does? It brings you we saw this, right? We saw how ReLU forms the boxes over here. We saw that, right? Exactly in the same data set we saw. Do you guys remember? See, it forms like lines, right? It just solved one line, second line, third line, fourth line, fifth line, sixth line, right? So it sends it through a ReLU layer. Then it again goes through a linear layer and then a new vector is being formed based out of this. What is a vector? Vector is nothing but this embedding is your vector, right? So that gets formed. Then basically what happens? They do residual. Okay, residual processing is, leave it off. I'll cover that separately. Just assume that they're applying layer normalization. I talked about batch normalization, correct? Here at a layer level, they perform normalization. So this is why you need to understand, we skipped the piece around neural networks and because, we wanted to get to the hands-on, right? So this is the piece where you can understand what happens at a layer level. So if let's say if this is your layer, right? So this is one of your layer. At this layer level, normalization happens. And again, at this layer level, normalization happens, right? So they do layer level normalization. Then once layer level normalization happens, how the meaning sharpens. This is again intuition. This is not the exact way the model may work. That is why we always say the model might work like this. The model might assume that the cat as an animal, the sat as an action in the vectors that it has formed. This is what is something that it might have as a relation, right? In the final layer, it might say that full meaning might be captured. I said, right, cat, sat, and wall are the important words. Subject would be cat, action would be sat, location would be wall. This is what is the outcome of the final transformer layer. So, and based out of this, out of the transformer, it just basically passes it to the decoder. But you may add any layer beyond this to, if you want to find the next word. After the decoder, you can add any kind of machine learning model to tweak it in any particular fashion. That's what happens beyond this point. Is this better, or you want to go layer by layer? I mean, I think it's better, Kumaresan. I will do that one-on-one with you because it might confuse others, because if I have to go multiple level down in order for you to understand that. But for now, at a high level, if you want to understand, you send in the word like the cat sat on a wall. The output of the encoder is cat sat wall. This is what is the output, basically. The important words get picked and then they get pushed out of the transformer outcome.
Okay,
I'll pause here. Everyone understands this, or is it complicated to understand? I need to know, because so that I can see in which way I can explain it even better. Do you want one more level down, or? So who did not understand this? Who doesn't understand this? All right. So I'm going to assume that everyone understood this.
But Bharat, are we gonna be anyway doing it in practical, right? So in terms of
Yeah.
building it.
Yeah. We did this already in practical, right? Yesterday we did.
So yes,
This is what we. Yeah, this is what we did in practical. But you will not work at these layer level itself in practical level. This is only for interviews.
Okay.
Yeah. Any other questions?
Bharat, this last thing. So just taking that, the comment from Kumareshwan, and also you were telling, right? So the cat sat on the wall, right?
Yeah.
Now, as he was telling, right? So the image, I can even give a prompt telling the cat sat on the wall, give me an image for it. It will give me an image.
No, it won't. That's exactly what I'm saying. Transformer model is different from other domains. You're talking about multimodal. Don't think that transformer model is ChatGPT. Transformer model is, if you give text, it is only a text model. It is not a image model, audio model, or video model. Those are different ones. So the architecture itself is very different for that. That may or may not use a transformer architecture inside of that model. See, transformer is like a piece of the puzzle when it comes to like ChatGPT kind of thing. Okay. So when you want to build a chat GPT, your chat GPT model may use a transformer architecture. And then it may connect this to an image generation model. The image generation model may take an image prompt as an input, the detailed prompt as an input, and then it may generate pixels as an output. And those pixels get converted into an image. Right? Like that, it differs. But ideally speaking, this cannot generate images and all of that. This is only for text.
Okay,
And
makes sense.
understanding the key aspects of a text.
So transformers are not basically used for any image generation, but it can be used for any text.
Yeah. All right. Any further questions? All right. So quickly recapping it back, Transformers has both encoders and decoders. GPT model is predominantly decoder only model. BERT is predominantly encoder only model. Okay. All right. No questions. Everyone understands this. Do you want me to explain something in Tamil or something? Please open up and please be, please tell me in normal sense that how you are getting it and in which way I can help you.
Bharat, here I'm not going too deeply on a very high level. I just want to let you know what's my understanding level and to confirm, is
Yes,
it right?
please. Yeah, yes.
So it's a very high level. So when any content is provided, any text format, generically it will do the tokenization, nothing but all words it will divide and convert into a numerical format. And
Correct.
again, it's the embedding process. In this process itself, of course, it will do multiple layer of shrinking along with understanding the text each other by having a correlation of each text. So it will do the shrinking process. So that's why wherever we are going to, we can apply this type of architect if we want to create a short summary or at the time we can make use of this particular architecture, right? Till this phase.
Yes, exactly. Yes.
Okay. Okay, and if you go with the reverse way, the existing text, shrinked text, we will be using as decoding process, a reverse version, and that it will generate provide a detailed output. Even with that output, also we can make use of generative of new text or huge summary.
Yeah,
This will
correct.
be the entire phase will be under the decoding phase.
Exactly.
So.
Correct. Exactly.
Okay, this primarily for a GPT, generative pre-trained text, this decoder process. Combined of both these things, like in case if I want to use my logic architect diagram for both, like compressing of data or giving a big, huge, detailed version of context and all, I can go back and use that transformer level architect into my
Correct.
code, right?
Correct. Yes.
Okay,
Yes. Correct.
okay, thanks.
Yeah. All right, cool. So if there are no Kumareshan, you are clear, right, Kumareshan? Or you still have doubt, or you still don't
No,
understand
no,
it?
no, actually, I mean, like I'm curious to learn in depth, Bharat, but it is okay that I understand that
See, no, I
whatever
can.
you said, it is okay, but little bit more deeper because I'm from semiconductor company, even your image, my image, how it is turning into the 0, 1 and storing it in the RAM, ROM, all these things I know. So I'm like going in depth something to understand better. So how it is again like using some
Makes
algorithm, it
sense.
is generating some things. So those
Yeah,
things I
yeah.
want to know. That's all.
No, makes sense. But the thing is, in order for that, in order for you to know that, that itself is a complete, what to say, like that itself is a huge thing to learn. Like that itself, you need to learn. This is not. It's not a quick thing to learn. Is what I'm trying to say. Uh, there's a huge. Um,
I
uh,
understand, but this is the
yeah, that's
first
a
layer
huge
of
space.
understanding
Yeah,
whatever
yeah,
you told, and
exactly.
again we have to go in depth, and then only we can dig out like what is behind these things. Yes.
Correct. Yes.
Mm-mm. Yeah, maybe we can like of course it is not a 1 day process. Like we have
Yeah.
to go
Not
in depth
just
at
that.
least.
It is not just about that. It is about you having to learn from neural networks. You can't directly jump in and learn transformers. You can never understand it because I'm saying this because I started learning with convolutional neural networks. Then I had to learn. I had to build neural network from scratch, in coding and everything, in order for me to learn it to that extent. Then only I was able to get back to this particular thing, right? So that is why I'm saying that it's a very tedious process to um, do that. But it's not that it's not possible or something. It is possible. But I'm just saying that it takes a lot of time.
Yeah, yeah, understand, but okay.
All right, cool then. So if everyone is good, this is pretty much I plan for today. So we will start with prompt engineering from tomorrow. And from tomorrow, it's going to be, I think it's from tomorrow onwards, it will be most 99% hands-on. So we're not going to learn any more theory from here on. It's going to be complete hands-on stuff from next session onwards, because we will start to do prompt engineering. Once we do prompt engineering, we will start to get involved into the um, RAG and other space, and then we will continue on from there on. All right.
Okay, Bharat, you mean the next week, right? Like okay.
Yes. Yeah. Yes. Starting from next week. Yeah.
Okay.
Yeah. Bharat, Mani here, Bharat.
Yeah. Hi, Mani. Yes.
Yeah, actually, Bharat, you gave some 4 plus 15 things, no, Bharat. In that first set, you just showed me how to generate the music through Sumo AI, right?
Correct.
Yeah, can you just explain in that 15? Can you just show me one example how we are using that? Some task you gave, no, today.
Yeah.
To just
Do you want to see some other example? Like this is basically, see, the task here is nothing. The task here is you basically going and using these applications. So you just take this. What you do is you go to ChatGPT or whatever it is, whatever platform you use, go to that, find a free tool that can generate engaging post campaign ideas, right? So first one it gives is Caption Studio, right? So let's redo this. Okay, it is AI prompts, right? So then what I'll do is I'll go into Caption Studio. I'll log into Caption Studio. Then I'll want to, yeah, I just want you guys to try these tools out to see how generative AI tools are being built as a user. First, if you use it as a user, then you can start, building such tools, right? So that's the idea.
Okay. I understood. Now I need to use 15 different things. I need to log in and I need to do some things there. Then only it will work, right?
Yeah, that is, yes, that is for
Hmm.
you to learn how to use these tools. That's the idea.
Oh, okay.
Yeah.
See, as you did know, like for Krita systems, I same like that I did for myself. Can I show that here?
Yeah, please go ahead.
Yeah. Are you able to see Bharat, my screen?
Yeah, I can see your screen. Yes.
Yeah, as you told, no, I gave some own lyrics of myself. Can I play a song here?
Yeah, sure, play. Yeah, you can.
Yeah.
We couldn't hear it after a few seconds, but this is great.
Oh.
I mean, you can send it on the WhatsApp group or something, whatever you're trying it out. Please send it out on WhatsApp group. But ideally, this is what is the thing that, you know, we want you to try, right?
Okay.
That's
Okay,
great.
Bharat, I'll try that. All the things I'll try.
Perfect. Yeah, that's great. Great.
Bharat, one more request. Like, so can we talk about some limitations of like current model? Like, see, if someone asks, okay, so, yeah, I know that it can do everything. It can do programming. It can do image processing, video processing, songs processing, everything. So, what is the limitations of current models, or like a current existing model, something like that? Can how we can say this?
Sorry, I didn't understand your question. Can you please repeat
No.
it?
See, okay. See, for example, what ChatGPT cannot do this, what Claude AI cannot do this, something like that.
So see, that is something that we will have to work in those areas in order to figure those things out, right? That is when you become an AI user, you use it. We cannot say just like that. I also don't have the knowledge to say that, okay, it doesn't perform good output here, because, you know, it requires a domain expert in order to say those things, right? So
Okay.
yeah, we cannot. So that's the reason why I'm saying that when you use such tools, you will get an idea as to, and you can ask AI itself for that. You use AI itself for that. What is the, why should I use Gamma.app when ChatGPT is there? ChatGPT presentations are not that great. Gamma presentations are much better. And Gamma app lets you to use not just ChatGPT, it lets you to use Claude, everything else. Like this, it will give you pros and cons, right? That is what is
Okay.
important.
Understand.
Yeah. All right, guys. Okay, fine then. Cool then. So then we will catch up again next week, but continue to, spend more time on this. Like give it a little bit more read, because all the theory portions are done until now, and we will only focus in on hands-on from here on. Okay.
Okay.
All right. Fine then. Yeah. Thanks a lot, everyone.
Thank you all. Bye.
Thank you.
Thanks.
Take care. Bye.
Thanks, Bharat. and
Thanks
Thank you
all.
all.
Yeah.
Thank you, Bharat.